Okay, so let's for this video, let's finish the dot product code before we move on to other things. So basically, okay, before I start, let me turn on screen key. Oops, screen key. Yeah, and what that will do is that you will be able to see my keystrokes. Okay, just testing this out. Yep, this works perfectly fine. Okay, so without further ado, let's start. Now, there are two things over here for unit tests. Okay, unit tests. So okay, why did I introduce unit tests? So for testing in general, let's not talk about unit tests, just tests in general. So tests in general should pass when the program behaves in the desired manner. So what I have here is that there are two failures. One is that the error handling, well, when we have unequal length, this test is failing. So where is that? Okay, this is the dot product error handling unequal length test. So where's the error handling unequal length test? Error handling unequal length test is here. Okay, error handling unequal length test is over here. Unfortunately, this doesn't, this doesn't so-called pass because I'm panicking. Yeah, I called the unwrap method on the result, and this basically just panics. Okay, so yes, we should expect an error for multiplying giving a dot product for two vectors of unequal length. So this is the correct and intended behavior. So the test should not fail. Okay, how do I make it not fail? Okay, so for starters, I'm not going to unwrap the value. I'm not going to unwrap the value. Right? And in fact, I'm just going to delete this whole line here. Okay, so this is I'll just call this a dot product result. Okay, of course this will pass, but I need to make sure that this dot product result is actually the correct result. Okay, this result is one of two types. It's the dot product result of F64 and dot product error. Okay, F64 dot product error. I need to do a matching. I need to match this result enum. I need to get the error dot product error out, and I need to make sure it is of unequal lengths, vector length unequal. So this is the result, and let's put up first. Okay, let's organize things. This is the intended behavior, which is the error. Okay, so I'm going to call this let intended error equals to dot product error, and this will be the vector lengths unequal. So this is the specific error I want to have. This is an error. So this dot product result, when I take out the error, I should have this error be, yeah, this dot product result right here. This error should be this vector lengths unequal error. So okay, it should be this vector lengths unequal error, and if that is correct, then we pass this test. How do I do that? Okay, so there are two basic ways. We still need to sort of have a match statement to get the error out. So I can actually do let error actual error equals to match. Okay, match dot product result, and I'm going to do the syntax here. Okay, I'm going to fill the match arms. Okay, so the okay, if this dot product result is not an error, then something is wrong, because these two vectors should not be able to multiply. We should expect an error. So this one will say panic. I will panic this one, and I'll say test failed. Rather, the code failed dot product function failed to catch error. I failed to catch the error, right? So here I should have a semicolon. That's what the compiler is saying. All right, so if it's an error, I should expect a dot product error. Okay, so this is the error. Okay, or the unequal or actual error. I'll just call this the actual error. So if this happens to be, if this dot product result actually contains this actual error, okay, then I will put this actual error here. Okay, let me change this. This is a very bad naming convention. I'll just say dot product error. Okay, so I'll have this actual error. This is the error that we have, and it should be the vector lengths unequal. All right, so run code. Okay, and now the last part is assert if these are equal. So this is the standard sort of I mean not standard. It's a very organized way to have your tests. Okay, you can search online for unit testing. They will more or less show this kind of pattern. Of course, there are some differences, and I'm not doing it in a professional manner. I'm not doing it in a professional manner, but this should be the way, right? Unit testing. Okay, go search about unit testing, and you will be able to see what this format should be like. I think there are some videos in C# or whatever other language, they will have this kind of format. Well, I'll just tell you the format straight off in here. You should have the intended result, okay, the intended behavior of the program. Okay, so this is a value that represents the intended behavior of the program. In this case, we have an intended error. Then we run the code. Then we see if this actual error or actual result of the program is equal to the intended error. So I'm going to do a assert equal actual error and intended error. Okay, I'm going to do a semicolon here, and this should pass. Okay, this should pass. Okay, so the dot product, well, I cannot assert them equal because I don't implement the partial EQ, the trait. So I'm just going to do this partial EQ, and this should pass right now. See? So the partial EQ enables us to check if one error type equals to another error. So this is what we mean by trait derivation. Okay, that's, if you want to go in depth, that's a whole new thing altogether. I'm not going to go through. I just say use it, do what the compiler tells you. If you don't want to learn that much things, you don't want to learn too much under the hood, then don't learn it. Yeah, it's not strictly speaking necessary. Okay, so this is where is this? So here it is. If the length is unequal, then we should have this correct error, the dot product error, where the vector lengths are unequal. Then I can do the assert equal to test whether I actually get this error. Okay. Okay, then the other way to so-called match these. Okay, match this statement. Okay, the other way to match this statement is to so-called do the zero, check this zero factor. Okay, I forgot this. I should actually change vector 2 to a vector of length 0. So both vectors will have a length of 0, so they are equal length, but you cannot do a dot product on them because it's undefined. Okay, we have vectors of length 0. We cannot do a dot product on them, so this should have an error. So again, I'm going to do the same format. So this is the intended behavior error where we have 0 length vectors. So I'm going to do let intended error equals to what? Dot product error vector length 0. Okay, this is the second type of error. Okay, here is where I run the code. Okay, here's where I run the code. I'm going to delete this and I'm just going to call this result. Okay, dot product result. Okay, dot product result. Come on. Okay, we have a dot product result, and this should be an error. Now the second way to so-called do this matching is using this what we call the if let statement. You will see this in Rust. Okay, if let. If let is a very special example of this matching. It means that, you know, I don't want to care about any other kind of result. For the enum, I'm just looking for if this enum, which happens to be the result, if this enum happens to be once of a certain value, then we execute a bit of code. Otherwise, ignore. So what's the if let statement? Okay, you can see here. Here's the Rust by example. I can leave this inside there. We have a match statement. We have a matching statement. So if this matching statement is some value, well, if it's this enum, it happens to be this some variable, some enum. Okay, you do something. If it's not, if it's anything other than this some enum, we use this underscore here, which is a wildcard. Okay, I believe we were doing this pattern right here in the previous videos. It is this line I'm highlighting right here. Okay, so if the score is not A or F, don't do anything. So if you want to, I mean, we can use the match statement like that. That's not a problem. But if no, the recommendation is that you use the if let statement if we are only looking for one particular variant of the enum. So it says here the match statement, yes, you can use it. Okay, for some use cases, when matching enums, match is awkward. Okay, so this is one example. If let uses is a cleaner way of writing this. Okay, so this is what the if let looks like. So let me explain it right in front of you what the if let statement should look like. And it's pretty much like this match result right here. So I'm going to try and convert this match result into an if let statement. Okay. Okay, so yes, this is the original match statement, which I'm going to paste here. Okay, and right, and I need to get the actual dot product error. How are we going to do it? So instead of getting this error, so to speak, I'm going to change things one at a time. Okay, first thing first, let's do the if let. Okay, of course this is going to be wrong, but I want to do it slowly. Okay, so if let actual error equals to match dot product result. Now we are not going to do it like that. I'm going to delete this part out. Okay, I'm going to delete this part out. So this first part here on the left hand side of the equal sign, that should be the enum type you want to match. Okay, so this is what the enum should be matching. And then on the right hand side, okay, so on the left hand side is the expected enum that you want, the expected so-called variant. So in this case, we're expecting an error variant. So this is what we want to do. We're going to match. We're going to have this intended result here. We expected an error variant, and we have a dot product error. Okay. So if this dot product, if this we are looking for this pattern for this result. So we'll put this dot product result on the right hand side of the if let statement. Okay, I'm going to put it okay, and this should be deleted. Okay, so if let error dot product error equals to dot product result. Okay, so if this dot product result is equals to this error, then we'll do something with this dot product error. Okay, otherwise we'll do something else. Okay, so look at this here. The actual error here, well, we can actually bind bind the value here. Okay, if I'm not wrong, you should be able to bind some value. Okay. Okay, I guess you could bind, but okay. Okay, to be honest, I'm not that sure. So I'm just going to use it like as such. Okay, so here's the dot product error I was talking about. Okay, this is the dot product error, and I want to do the assert equal dot product error and intended error. Okay, so that's what we need to do. Okay, I wonder if there's an else. I'll just do a panic. Failed to get error. Catch intended error. Okay, let's see whether this code works. Okay, so yeah, so if let product error. So this if let statement, you can actually do it like a if else loop. So well, maybe I'll not do the else loop first, but I can do it like such. Maybe this is easier to read. Okay. Okay, so this part is the if, let, and assert. Okay, so what is this if let statement doing right here? Okay, what is this if let statement doing? Right? Let me do a return as well. Okay, so what's this statement doing right here? So here's our intended error, just like we have it before. Now we have two vectors of 0 length, so we should be able to get a vector length 0 error. That is the correct error. Now the result is as such. We do the dot product of vector 1 and 2, we should get a result. But because those two, but since we have vectors of 0 length, then we should have a vector length 0 error. So how do we get the error out? One way is to do the match statement, as we done before. The other way is to use this if let. So what's this thing doing here? So I'm trying to match this dot product result. So the dot product result comes here. So for the match statement, you have the dot product result on the right hand side. Okay, you have the dot product result on the right hand side of the equal sign. So the if let statement is also the same. You have the dot product result on the right hand side, but you don't use the match keyword anymore. So the if let statement, instead of you doing the match arms here manually, you shift this piece up here. So you have the error dot product error. So you shift the enum that you want to match and you put it on top. And of course you put the if keyword here as well. So if this dot product result happens to match this arm, okay, then execute this piece of code. And then of course you will be able to extract the particular error type. So the error enum will have this dot product error within it. Then I can run my assert equal code. And once I'm done, I do a return. Okay, that means I will finish the test. I'm done. Okay. So there are a few ways of writing this return, but never mind, I'll just leave it here. It is. So if you do not catch the error, so to speak, if you don't catch the error, then I'm going to do a panic, which means I'm going to fail this test if I'm not able to get the correct error. Right? Or yeah, if I'm not able to get the correct error. So that's what this test is trying to do here. Okay, so this is just some way to make sure your test runs a bit more clean and in an optimal manner. And that's what if let statements are there for. You will be able to see lots of if let statements in Rust code bases. So if you ever run into if let statements like so, just know that they are very specialized and a concise way of writing match statements. but you are completely free. You're completely free to use match statements as and how you like. You don't have to use if-let statements if you don't want to. Okay, this is just for information. If you ever see if-let statements in Rust code bases, this is what it's actually doing. Okay, so now we have our tests all running okay. Okay, for the dot product multiplication, we have the cubic roots thing running okay. So all of this seems to be good so far. Now before I'm going to close off soon this video because I want to move back to the Ping-Robinson equation of state stuff. But before that, I want to sort of clean up all these errors right here. Okay, so to move up and down in tmarks, this is what I'm going to do. Control B up and down. Okay, so Control B, yeah. So all of this in the cubic roots, I want to allow them to have a non-snake case name. Okay, the snake case, it's basically the case with small letters and underscores. We call that snake case. Okay, I want to allow these variables to be a non-snake case. So I'm just going to clean up all these errors so that, you know, the compiler is cleaner, it looks better. Okay, I like to clean up all these warnings before I move on and do new code. Why? It makes debugging a lot easier when I see, you know, maybe 3 or 4 error messages at most. Ideally, I only want to see 1 error message, but I might be seeing 3 or 4 error messages at one go. Okay, so and that's fine. But the thing is that if I leave these warnings here, and then there are like 50 something warnings, it can make finding that error a little bit difficult. So I do not like to have warnings constantly display like that. Okay, so to get rid of the warnings and to sort of tidy things up before I move on, this is how I do it. So first, let's deal with the non-snake case. Okay, the non-snake case things are okay, quite straightforward. Well, straightforward to me may not be straightforward to you, but this is how you're going to do it. Okay, I'm going to look for where the warnings are. Okay, so for example here, this is one warning. Variable A should have a snake case name. Variable B should also have a snake case name. Now, to allow this non-snake case name, okay, I'm going to do this. I'm going to do allow, and I'm going to put a non-snake case right here. And once you do that, that warning will be gone. I'm going to copy and paste this. I'm going to allow non-snake case for this particular variable. Now, you're able to, of course, do it for the entire function as well. You can do a allow non-snake case right here. And that is totally fine as well. You might see this in some code bases, but I like to be very, careful, right? Very careful of where I put my where I disable this. This is what we call linting warnings. Linting is where the process where, for example, here you will see beside your code, here are the potential warnings or errors. This is called linting. So I want to get rid of some of the linting, and I want to be very particular. I do not want to remove all the linting. I only want to remove some of the linting. Okay, so right. What's the next thing? Okay, see, get yk here is never used. So this is the cubic roots line 65. How do I know line 65? You will see here, source cubic roots line 65. So let's go to line 65. And here is the function that, well, we apparently never use. Okay, so where is get yk used? Okay, I'm just going to, since it's never used, I'm just going to comment everything out. Okay, that's one way of getting rid of the error. The second way is, of course, you just put an underscore here. The error will also disappear. I can just put it here as a redundant function. Okay, I don't use this anymore. It's a redundant function. Okay, next thing is that get molar volume Ping-Robinson gas is never used. Okay, this is not done yet. Okay, you can go to source preos. Okay, so all of these things here, they are not done yet. So we'll not do the error things here just yet. Okay, last but not least, okay, let's go and look at all these things here. Get temperature, ping Robinson guess is not used. 5 degrees here is also not used. So this is there are a few things you can do. You can just delete this entire code, or you can comment it out. If let's see what line it is first. It's on line 108 of cubic roots. Okay, let's go for cubic roots line 108. Comment it out because you don't really need it, or even better, just delete it. Okay, just delete it. Okay, let's update again. Okay, so all of these imports are not used, so let's get rid of this. These things I still want to use them for later, and this is in the idealguess.rs, and we want to use them later as well. Ping Robinson eos.rs, I also want to use them later as well. Okay, cubic roots degree is not used, so let's remove this import as well. Okay, I'm going to delete this, remove all unused imports, and let's unmerge, remove unnecessary braces. At least makes this code a little bit neater. So we have 14 warnings right here. Most of them have to do with some what do you call that? Well, our code is not finished, so we will deal with the rest of the warnings later. Any warnings to do with cubic roots, we have sort of settled them out. And of course, for the dot product also, we also got that settled as well. So for now, I'm done. Gonna add this all to Git. Clean up errors. Okay, I'm gonna push it to GitHub. And that is all for this video. I'll see you next time.